Hey guys, this is Wojtek from Jolly Monster Studio, and today we're going to look at part 3 of our Play Character series, talking about collision events. In this lesson we're going to take a look at how to use delegates to trigger the OnComponentHit event. We're also going to look at expanding our delegates, and I'll show you how to quickly get at their method signatures, so we can look at the OnComponentBeginOverlap as well as the OnComponentEndOverlap events that allow us to basically interact with the collisions when they go through each other. And then lastly, we're going to take a brief look at the FHitResult object that our component hit delegate is going to generate. And this is the struct that contains various properties around our collision, points of impact, who we're impacting, and all kinds of interesting bits of information. So, let's get started. Before we dive into our C++ code, let's just take a look at what collision events look like in our blueprint. So, if we go ahead and pop open our third-person character blueprint, we can then navigate over on the left-hand side to our left fist collision box, or the right fist collision box, and you'll notice on the right-hand side, under the events section, we have a whole pile of different events we can look at. We have component hit, begin overlap, and end overlap, as well as component wake, sleep, and a bunch of other ones that are tied to clicking, releasing, input manipulation, things like that. In our case, we're just going to look at OnComponentHit because I want to show you what it does when we actually tie it all together. So if we go ahead and just add that component hit event, we can then simply say in our blueprint to print a string. And this is going to be our right fist event, so right hit event, and then we'll do the same thing for the left hand side. So pick the left fist collision box, go to events, on component hit, and we're just going to do another print string, and there's left hit event. So when we now run our game, you'll notice, no collisions. Our events are not playing. The reason they are not playing is, in addition to the events, under our collision section for each one of our collision components, you also notice this little line that says simulate generate hit events. And without this checked off in your blueprints, or without this boolean turned on in your C++ code, the hit events will not generate, and you'll be stuck with this half-working implementation. So let's turn on the hit events and restart our game. Now, when our collider interacts with our enemy object, you'll notice I get our left hit event messages being printed. So that's pretty cool and really quite powerful, because now we have the ability to start tying our impact events, our hit events, our overlap events to whatever mechanics we want. We can add sounds and particles and all kinds of neat stuff. So let's look at transposing this logic now into C++ code. Now before we get into our C++ code, let's just clean up our blueprint. We're not going to need this anymore. And then let's go ahead and reset these collision hit event notify booleans. Compile, and there we go. Now back in Visual Studio, let's take a look at adding in our delegates to mimic our blueprint functionality. So let's pop up in our play character CPP file, and not within the constructor, but rather within the begin play, we're going to add our delegate calls. Now the constructor sometimes has issues where the construction script from the blueprints may override these definitions. Not always, but sometimes you get these weird behaviors. So it's recommended that when you're doing things like attach to components, the definition of our dynamic delegates, we do that in begin play. Begin play is basically post constructor definition, but before anything serious happens within our game. So it's like a little initialization method. And right below our attach to component definitions, where we attach our components to our sockets, let's add in our delegate definitions. So if we grab our left fist collision box and look at its various methods, we can very quickly find our OnComponentHit definition. To that, you make a reference to the add dynamic delegate definition, which will allow us to pass in our user object. So that's the object that the function name is attached to. So in this case, it's going to be this, because we're going to pass in our player character. And because we don't have a function for this component hit operation just yet, we're going to stub it out. So we're going to say a player punch kick character, and we're going to say on attack hit. And since we don't have this method yet, we're going to go ahead and define it in just a second, but let's reproduce this for our right fist collision box. There we go. So what this is going to say is on this event provided by this object, pass in myself, and then make sure this operation is triggered on this object. So because the signature is not available, let's go ahead and define it. So let's pop up in our header definition, and let's just stub it in again around our attack section. So it's going to be on attack hit, and we're going to leave the signature definition empty for right now, but let's just put a comment around it. And this is going to occur, so triggered when the collision hit event fires between our weapon and enemy entities. Now, we can't just pass in a void method with no signature definition into these delegates, because they actually expect a handful of parameters to be passed down. So to figure out what that actually entails, because as you saw in our quick intro at the beginning, the documentation isn't all that great, but because you have access to source code, you can very quickly navigate to all this stuff. So holding that control, we click on OnComponentHit, and IntelliSense will just take a second to traverse down and find our definition. And there we go. So this brings us into the primitive component header file, which, as you can see, has an extensive amount of documentation on our OnComponentHit. But more importantly, it makes a reference to this guy here, FComponentHitSignature. And this is the delegate definition for what the method signature needs to look like for this guide to get processed. So if we control-click on FComponentHitSignature, again, IntelliSense will take a second, and it'll take us down to the declaration of this delegate. So you see there's a handful of conventions that the Unreal Engine uses. Things like, hey, declare dynamic multicast delegate, and there's different sort of combinations of these keywords. And then they pass in the number of params that this method needs to have in order to function correctly. The first argument for the delegate is also going to be the FComponentHitSignature, which is sort of the definition of this delegate, and then the rest of it is basically data type, variable name, data type, variable name, and all the other parameters that will go into our method signature. So to reproduce this in our code, we want to grab everything past the name of the delegate, just copy and paste that into our onAttackHit. Now, because the delegate definition has commas after every data type, you need to go in and just turf those. And now we have a matching signature, or sorry, a matching set of input criteria for our OnTalkHit signature that matches our delegate definitions. If you don't have this lined up one-to-one, when you compile, and the compiler hits this line of code, it's going to get all freaked out and you're going to have a bad time. So just make sure your signature definition is correct. Now, let's go ahead and implement this signature, because having it in the header is not going to do us much good. And I'm just going to drop it right below attack end. And let's make sure we include our class definition. And then let's just take this log entry and pop it in here as well. And we're going to make this a warning just so we have a couple of different colors showing up when we're doing stuff. Okay. So we have our delegate, we have our method attached to it, and the only thing we're missing, as you recall, if we go back to our blueprint, is this little boolean, simulate generate hit events. And the one oddity with this boolean is it's not called by this name in C++. So if you were to look for that specific definition, you wouldn't be able to find it, but we can certainly get to it through a different variable name. So before we get too far, I also want to mention that we want to make this setting available when we fire our punch and turn it off when we're done our animation. So we already have these attack start and attack end methods, and in here this is where we're going to turn on our hit events. So the variable name is set collision set notify rigid body collision, and this translates over to the generate hit event setting. As to why Epic decided to keep these completely different, I don't know, but it has caused a bunch of confusion for folks trying to find this. And once we turn it on, we also want to make sure it gets turned off. So in our attack end, we will say set notify rigid body collision to false. Oops. And right. Okay, so that turns on our hit generation and turns it off when our animation ends. And we're going to do one more thing, because we want to be preemptive and make sure there is no generation of hits occurring when we don't want it in our constructor. We're also going to say set collision notify, set notify collision rigid body collision to false. And we'll set the right one too. Okay, so let's recompile and take a look at our project. Now with our project recompiled, I'm going to pop up in Unreal, and you'll see this bit of work that we just did actually not working. And the reason it's not working is a very common problem that a lot of folks seem to have, and it's due to the fact that when we defined our onAttackHit method, it wasn't decorated with the uFunction macro. And I'm not sure where in the documentation this is even mentioned, but certain method definitions, especially ones that are tied to delegates, like we're tying our onAttackHit to this onComponentHit, require this decorator. And uFunction, similar to uProperty, allows you to basically expose certain method and property signatures to the Unreal Engine for sort of its nefarious needs. And if you don't get your project working for your delegate hits, chances are you're missing this declaration. And this is something I just learned through trial and error and spelunking through various forums, so I thought I would share it with everyone. But yeah, let's now add it back in, recompile it, and we should see our collision hits now being registered. Okay, there's our recompiled project, and now let's restart the game. There we go. So you can see when we collide with the box, we now get this additional event being triggered through our code. And this is pretty cool. We can now start tying in all kinds of logic. So for example, on attack hit, we can, subtract from the health of the box by whatever the damage being caused by our fists is. We can trigger sounds, we can trigger animations, particle effects, all kinds of stuff. Now let's flip back to Visual Studio just for a second, and let's take a look at our onAttackHit method. You'll notice we're doing our logging, which is fine and dandy, but it's not super informative. The other arguments, though, that are being passed in this method are quite interesting. We have our hit component, so the thing that's instigating the hit, so we can get information about our left or right collision box, depending who's calling this. We have our other actor, so the thing we're interfacing with. We have the other components, so the thing that triggered the interfacing from this other actor. We've got some normals, and then we've got this hit result struct. And this guy, if we control-click into it, he's actually quite interesting. You'll notice he has a pile of different attributes, properties that are of interest to us. So we have, hey, was it a blocking collision? We can get the face index of the thing we hit, the time, the distance, various locations and impact point vectors and normals. So all of the sort of space, all the attributes that define the point in space where this collision occurred. Trace start, trace end, penetration depth, additional information we want to pass around, and then you get into some interesting stuff like the physical materials, actor, the various components, bone names. But more importantly, you get all kinds of sort of free information coming out of this hit result. Now, in our case, we're not going to do too much with this just yet, but in subsequent tutorials, we're going to use this to basically trigger damage and handle critical hits and things like that. But for the sake of this exercise, we are going to just replace our function call with getting the name of the actor that is being hit by our left or right collision boxes. So we're going to say hit get actor, and then we're going to say get name. And let's just recompile that and see what it looks like in our game. Okay. And there we go. So you can see, by interrogating the various attributes that are being passed into our method, we can obtain all kinds of interesting information about the things we're now colliding with. So in this case, we're just printing that it's a 1 meter cube, and that is the name of the object. And that's pretty neat. So let's now go ahead and take a look at what it would take to introduce overlap events. We have hits, but now we can go ahead and, using this exact same paradigm, generate overlap events for our player colliders. So to do that, let's go to our header definition, and we'll stub in 2 new methods. U function on attack overlap begin, and another U function on attack overlap end. And similar to this method definition, we're going to get these signatures and stub them in. So, going back to our CPP file, navigate up to the begin play method. And actually, let's just do it below. So left collision box on component begin overlap. Add dynamic. This punch character on attack overlap begin. A little bit of dyslexia and naming conventions, but that's okay. Left fizz collision box on component end overlap, and we'll do the exact same thing. This, and we pass in our character definition, and then on overlap end. Oops, and this should say add dynamic. Now, you'll see this little red underline. It basically says, hey, you're trying to assign a delegate call to a method signature that doesn't match. So let's go back to our primitive component and trace down the actual method signature. So there's our OnComponentBeginOverlap signature definition, and there's the end signature definition. So let's grab these parameters, go back to our header file, get rid of the additional commas, and there's our overlap begin signature definition. Back to primitive component. Let's grab the end and do the exact same thing. Okay, now let's look at actually implementing these methods. But before we go too far, let's just make sure we add some commentary so we know what these guys actually do. Triggered when the collision, when the collider overlaps another component. And this guy is triggered when the collider stops overlapping another component. Okay. And let's now go ahead and add these implementation details. So go back to our CPP file, scroll down to our onAttackHit, and right below that, we're going to introduce these two new methods. And we're also going to do the end. Okay, now let's go ahead and add in some log statements. But before we actually compile this and run it, we have a couple of things we need to tweak. So our collision definitions from our last tutorial, and to check that, we can go back to our Unreal editor settings, project settings, collisions. So in our last tutorial, we set these collision presets for our weapon and enemy to block each other. So the weapon profile blocks the enemy, and the enemy profile blocks the weapon. And if we're going to do overlaps, we can't have blocks. You'll notice this is not a... it can do all the things, it will do just some of the things. So we're going to set our enemy collision profile to overlap our weapon, and we're going to set our weapon collision profile to overlap our enemy. And you always want to make sure that both sides of the collision detection are set correctly. Otherwise, you'll have some issues. Now, similar to the setting we put in our attack start and attack end methods, the set notify rigid body collision, there is also another Boolean that represents the overlap events. So if we go back to our Unreal editor, third person character blueprint, and just pop open our left and right collision boxes, you'll notice there's this guy here, generate overlap events. And it's another Boolean, and you need to make sure it's either set in your blueprint or C++ class, wherever you're actually triggering these collisions. So, in the spirit of our attack end and attack start animation notifies, we're also going to augment these collision boxes with set generate overlap events true. And then we're going to turn them off. Sorry, let me just copy that. And then we're going to turn them off in our attack end. Okay, and one thing when I was copying the log levels, you'll notice the hit attribute is no longer available. But we have a couple of other things we can reference. So in this case, let's say other actor, and we will get his name. And likewise in our end. So what did we end up doing? We added new method signatures for our overlap events. We tied them to our delegates. And it's a good thing we came back here because I forgot to do it for our right fist collision box. So we added our delegates to our method signatures, and then we just implemented them with a couple of log statements. So let's recompile. Actually, before we recompile, let's just make sure we know which methods are being called, because I realize we're passing in the same parameters. So let's just pass in the function identifiers instead, and then recompile. Okay, great. Let's now open up our game. And you'll notice when we interact with our box, we get our overlap begin and end events. So that's pretty much it. Before I save this project, I'm going to go ahead and revert our overlap events. So just go back to our hits. And to do so, we'll just quickly run through it. So we're going to go back to our settings, project settings, collisions, down to our weapon, and set our weapon to block our enemies, and our enemy, and we're going to set that to block our weapon. And then we're simply going to clean up our code by removing the references to the overlap method signatures. Now don't worry, we're going to revisit overlaps in subsequent tutorials, but right now we just want to leave the hidden. So get rid of that guy, and then let's turf these two methods. We're also going to go ahead and clean up our overlap. So basically anywhere we have a reference to our set generate overlap events, we're going to get rid of those. As well as our delegate definitions. And this way we should be back to just using our hits. I think that's it. Let's recompile. Okay, we should be back to normal, and now when we start our game, we're back to just generating our hit events. Cool. So this is going to be now the baseline project for our upcoming tutorials, where we're going to start adding in sounds. Whenever our player hits something, it's going to make a noise. Exciting. Thank you for tuning in, and I hope to see you guys next time.